of calculus is what we started off with, because if f of x is going to be any function in the closed interval a to b, like in an interval a to b, I have a function f of x, then its definite integral was f of b minus f of a. All right, calculus function. So, okay, we did this with algebraic expressions yesterday. We can, you remember what we did? I'll try to recollect one with regular function, then I want to move on to the trig part, okay? So the first example, it was one of your homework, but, so the first problem that I want you to try, the antiderivative, if I have.
So we can.
From -1 to 2, x plus x squared dx. Remember we had something like this? Yes, we are starting with algebraic expression. Now then we'll move on to trig. Okay? So I'll walk you through this.
I know how to do this.
Yes. Correct. Once you find, step 1 is to find the antiderivative. Step 2 is to substitute the upper limit and then the lower limit. Yes.
So you need to find the antiderivative here to derive everything.
Correct. To find the antiderivative of each of them. So antiderivative of x would be x squared over 2. X squared over 2. Alright? What about this? X cubed over 3. And then, since it's definite integral, we put down the limits. The lower limit is -1, upper limit is 2. So what did I do from here to here? I just found the antiderivative. Is this step clear to you? Are you following? Okay. Now what did we do yesterday?
Then we substitute the limit in the upper limit in
Correct. This next step is to substitute the upper limit. The upper limit for this function is 2. So I substitute 2 over here. I get 2 squared, which is 4 over 2 plus 2 cubed is 8 over 3. This is the upper limit. So this is the upper limit. I substitute, what did I do here? I substitute -2. Oh, sorry, I substituted 2 in this expression. So upper limit minus lower limit. So minus, each time you do this, please put parentheses, because you know that that's the upper limit. So upper limit is over, this is the upper limit. So close it. Now minus the lower limit, because you'll mess up on the minus side. That's the fundamental theorem of calculus. You have f of b minus f of a. Remember the area between the two, it is the upper limit, f of b minus the f of a. That's the formula that you're using. That's the concept you're applying. F of b, so f of b means I'm first applying the upper limit to this, minus the value of this with the lower limit. Okay? So yes, do you have a question? After. So that's the reason you have to do that. But keep it here for now. So now -1, substitute -1. So when you substitute -1 here, you get -1 squared is +1. So 1 over 2, alright? Upper limit. So, and then -1 cubed will be -1 over 3. Are you following? Now basic fractions. To find the common denominator. So 6. So that would be yes. So you have 12 plus 16. So which is 27. 28 over 6 minus 1 over 6. So that will give you 27. Okay? You understand? So the steps are clear. You take the function, the given function, find the antiderivative. From here to here, sorry, what I did was the upper limit value minus the lower limit. Sorry? Sure. Understand? So the trick, now you have to remember your unit circle. That's the whole thing, the trick.
So that's the fraction, 27 over 6.
27 over 6 would be the answer. So for definite integral, you will get a number as the answer. Because you're finding the answer, you're finding the area between these two. So obviously it will be a number.
Would it be?
Okay, what happened?
I was say, would it be squared?
Would it be the units you mean? Yeah, we could, but here, when you come to actual problems, then we put units. Here we are practicing how to integrate a function. Okay? So the next example is based on trig function. I want you to try that. So number 2. Zero to pi over 2 sine x over 5d. Okay. So I give you 2 minutes. Try how much of it you can. 2.
Is that 5?
5. Pi over 2.
Over 0?
0 sine x over 5. Let's try it. Follow the same. Antiderivative of sine x. Look at the list. The antiderivative. This is the birds. I have put on concept. My mind is. Sorry, since the time I did not click on the time. Yes, over 5, not x. Yeah, the 5 is a constant. Remember, the 5 is in the denominator.
So it's not
We are not going to do that. Okay. So here, remember, like how you had.
We have to take the unit circle.
Now we have to. So what do you get once when you?
Cosine x.
Good. What about the sign? Is it positive or negative?
negative.
Negative, correct. So negative. So this is going to be negative 1 over 5 cosine x. 0 to 5 over 2. Because this number, it is going to be, it's not just cosine. You're following? Are you following? So, remember each time you have a coefficient, we take a constant, we keep the constant, and then find the antiderivatives of the actual function. So the constant over here is actually 1 over 5. You see that? Therefore, we keep it out. If I have to split this, I will write this as 1 over 5 and then sign it. Are you able to follow? Like how you had, see, yesterday you looked at examples where you had 2 sin x. Remember?
Yeah.
So what did you do? You kept the 2, right? The same way, you keep the 1/5. And now, so keep the 1/5 as a constant, leave it out.
Would you write the line between?
Leave it up.
Would you write the line between?
No, the line is at the last, like this. So, now upper limit minus lower limit. So the upper limit is, yes?
So you put the negative from cosine to the 1/5.
So 1/5 negative is because sine, the antiderivative of sine x is negative cosine x, right? But then we are multiplying. So when you multiply, you put the minus up front. So therefore you leave it like this. And when you have a constant, you don't have to include the constant in this computation. So leave the constant out. Upper limit will be cosine pi over 2. See, in place of x, I'm substituting the upper limit.
1 over 5.
It's a constant, so I don't have to keep multiplying. I can multiply my
Oh, I see.
final answer to that. So you can,
Basically, like, tracked it up.
that's right.
Yeah.
So you understand how we substitute for trig functions? So cosine of pi over 2 minus cosine 0. You following? So now, cosine pi over, so you simplify it after this. So cosine pi over 2. Now remember your unit circle, but cosine pi over 2, obviously you'll remember one. Got it. 0. So what you have is cosine pi over 2 will be 0 minus, what is cosine 0? Got it. So 0 minus 1 is negative 1, right? So this will be negative 1. So negative 1/5 times negative 1 will be 1. Yes.